Okay, so what we're going to do now in chapter 3, we start talking about functions, and you'll probably have some of this in your background. So basically what a function is it's a relation between two sets, set x and y, and basically each x is going to correspond to exactly one element of y. I'll show you enough examples on this. It's a real simple idea. But you basically have two sets, you have x and y, and they have to relate to themselves in a special way. Okay, the domain of a function is the set of the first elements. So and you want to write on there, that just means that's the value of x's. The range of a function is all the second elements, which would be the y values like that. So that would be all the values of y. Okay, so to start kind of talking about what a function is I'm going to look at what we call mapping diagrams and kind of show you what this is. So you want to be able to take a mapping diagram and tell whether it's a function or not. So really all you got to do is you got to ask this simple question, okay? Does every member of set x map to exactly one value of y? So notice that 5 goes to 1y. That's what that arrow says. 9 goes to 18. 13 goes to 26. 17 goes to 34, okay? So does each x have one y? Yes, so that means it's a function. So if you had a situation where you had an x that was going to 2 or more y's, then it's not a function, okay? Now what the domain is, what do you look for the domain? You just look at all the x values, okay? And in this case, you just write this as a set. So you just say the domain is 5, 9, 13, 17, like that. Okay, it's a function, therefore its domain is the set of all those x values. Okay, the range is the set of all the y values. Again, you just write this as a set, so you just say 10, 18, 26, and 34 like that. So that's kind of what a function looks like, is you want to make sure that every x goes to exactly one y. It can't go to more than one y or it's not a function. Okay, does that make sense? Okay. All right, let's look at what this next one is. Okay, so here's what we have on this. We want to ask the question, does each x have one y? Now you can use names. It doesn't have to be numbers. Math can be shapes and names and all kinds of things. Okay, so let's see. Ken likes Jill. Okay, so he's only got one partner. Okay, how about Brad? Brad and Kathy, they go together. Look at poor old Carl. What's wrong with Carl? Carl's a two-timer is what I'm thinking. Okay, so Carl's kind of a bad boy. He's got a crush on Kathy, and at the same time, he's got one on Becky. Okay, so that would mean the answer to that question is no. Carl, basically, that x is going to two y's, so it's not a function. That's a pretty good way to explain that. Okay, so no bad boys. All right. Everybody with me there? Okay, now really on this one, usually we don't even do the domain and range unless it's a function. So if something's a function, then we usually go ahead and write down what the domain and range is. So that's not a function because of old Carl. All right, everybody with me? Okay, all right, let's see how about this one. Okay, now let's see. This one we have Bob goes to Mr. Barr, Ann goes to Mr. Barr, Dave goes to Mr. Barr. So the question is, does each x go to one y? Yes. Yeah, okay, it does, okay. Okay, they all are interested in the same person, for whatever that means, but it's still a function, okay. Bob, one person. Okay, so that is a function, all right? Okay, so what you look for is you just make sure that the x's don't go in 2 or more directions. That's the idea. So the domain on this would just be these people. I'm just going to use letters, B, A, and D, bad. Okay, then the range is going to be Mr. Barr like that. Okay, that's the idea. All right, okay, everybody with me on what I mean by something being a function and not being a function? Okay, now sometimes they're in a mapping diagram, sometimes they're not in a mapping diagram. Well, you don't have to do anything on this example 4 except do it in your head. But what I'm going to go ahead and do is I'm just going to write down the x's. I have -7, -3, 3, and 7. Like that. Then I'm going to write down the y's. There's only 2 y's. There's a 2 and then there's a 9. So if you look at this table, it's just saying -7 maps to 2, -3 maps to 9, 3 maps to 2, and it's saying 7 maps to 9. So the question is, does every x go to 1y?
Yes.
Yes. Okay, so that is a function. You don't have like a -7 going in 2 directions. That's when it's not a function, if you have something like that. So that is a function. And again, you don't have to draw the mapping diagram. You can just do that in your head. Every x goes to 1y. Okay, so the domain on this would just be -7, -3, 3, and 7. Okay, you just put that in any order, usually numerical order, and then the range, there's only 2 elements of the range, or 2, 9, so you write that like that. Okay, so that kind of introduces you to the mathematical idea of what a function is it's got a, basically every x has exactly 1y. If that fails, it's not a function. Okay, okay, so now the next thing's real simple, is applying the definition of a function is something we call the vertical line test. And it's helpful to understand why this is, why it works. So if you have a graph, you want to be able to quickly tell if a graph is a function or it's not a function. Okay, so what you do is if any, the key thing is any vertical line passes through exactly 1 point, then the graph is going to represent a function. Okay, if you can find a vertical line that passes through 2 or more points, then it's not a function. Okay, and what it's doing is it's doing the same thing that the definition of a function is doing. And you can just do this in your head. So like on this number 5, if I take a vertical line there, it goes through 1 point. And what that means is that means that x value has 1 y value. That's what you want. And it doesn't matter where you are. If you take a vertical line there, that again means that x value has 1 y value. So does every single vertical line pass through 1 point? That's the question. Yes, okay, so that's why that's a function, okay? You're just trying to make sure that every x has 1y. That's what the vertical line test does, okay? The next one, okay, let's take like a vertical line going through like this. Okay, so notice on this one, it goes through 3 points. Now what this means is, this would mean x is going off into 3 directions, and it has 3 y values. That's why it's not a function. So that's not a function. That's what the vertical line test does, is it's trying to find an x that has more than 2 y's. Does that make sense? Okay, I mean, it's easy to do the vertical line test, but it's important to understand what it's doing. Okay, so that one's not a function. Okay, how about the next one? It's just a line going this way. Would that be considered a function? Yes. Absolutely, because no matter how you draw a vertical line, those vertical lines are always going to go through 1 point. So it just means whatever x is, you're going to get 1y. So that's a function. Okay? Right? How about the next one? This one's kind of weird. No. Okay. How do you draw a vertical line through a vertical line? Well, the vertical line, you would only go like that, and how many points would that go through? An infinite number of points, right? Okay? So that fails really badly. So that's basically what this means, is 1x goes to an infinite number of y's. Okay, so that fails. Okay, a vertical line is not considered a function because it fails the vertical line test. Okay. Okay, so that part right there, vertical line test, usually very smooth for students. The next thing is where I find students have a little bit more struggle with in this section. And the idea is you're given an equation and you want to reason out whether it's a function or not without graphing or anything. Okay. So this is basically what you got to do. You got to try to answer this question. Does each value of x give you exactly 1 value of y? Now you got to think about this. These are thought problems primarily. So what I want you to think about on this number 9 is, if we plug in a number for x, okay, any number, how many answers would you get there? Okay, if you plug in 0 there, how many answers are you going to get? 1, right? If you plug 1 in, how many answers are you going to get? Okay, so no matter what happens, no matter what x is, you're always going to get 1 answer to y, right? And that's the key. You just sort of do that in your head. You realize, okay, no matter what x is, I'm getting 1 value of y. Okay, so the answer to that is yes, you're going to get exactly 1 value of y. Sometimes that happens, sometimes it doesn't. Okay, does that make sense? Okay, so no matter what x is, you get 1 answer. Okay, and by the way, you guys already know this, what does the graph of 7x minus 8 look like anyway? It's a line. It's a straight line that has a y-intercept of -8, so it's a line that's sloping. And in your mind, a straight line like that would pass the vertical line test, wouldn't it? Okay? But your goal is to try to do this as much without graphing as you can. Okay, let's look at this. And again, I just say think of this. It's helpful if it's solved for y. So we're just going to take any number and plug it in for x. Let's think about how many answers we're going to get. Okay? Now, you can't put two different answers there. You just take your pick. Like, if x is 0, you would get one answer, right? So what if you just plugged in any number for where the question mark is? How many answers would you get? 1. Okay? So if you do 4 times a number squared minus 8 times a number minus 9, you're going to get one answer to that arithmetic problem, right? That's a basic arithmetic problem. So you're always going to get one y value. So that means that that is a function. Okay, that's the idea. Does that make sense? Okay. Now look carefully at the next one. There's 2 ways to look at this one. Okay, I'll show you a couple of ways to look at this one now. Okay, so the question is, does every x have exactly one y? Well, let's find out. Okay, let's use something like 1. Let's just let x be 1, and let's plug it in. So you would have 1 equals y squared minus 3. Now what we do is add 3 to both sides. And in your mind, you can add 3 to both sides, so you'll have y squared equals 4. How many answers does this equation right here have? That's what's important. There's 2. You do the square root of both sides, and you're going to get 2 answers. You're going to get y is going to be equal to plus or minus 2. So here's what we figured out on this. Okay, if we have x, that can go to 2, and at the same time 1 can go to -2. So is that a function? No. You just found an x that has 2 y's. You can't have that. So that's no. Okay, and what I did on that is I just plugged a number in, and I found one place where that happens, and that's all that matters. Okay? Now here's what I would suggest that you do on a problem like that. You can do it that way, but one of the best things to do is, if you can, take the equation that I've given you and solve it for y. Because it's usually even easier to see that way. So what I'm going to do is move the 3 to the other side. You can do that in your head. So you would have x plus 3 is equal to y squared. If you're going to solve that for y, what are you going to do now? You're going to do square root of both sides, right? And when you do square root of both sides, don't forget that you have a plus or minus like that. Okay, now what that's telling me is if I plug a number in for x, I'm going to get 2 answers, right? Okay, like if x is 1, I'm going to get plus or minus square root of 4. That's 2 answers. So if you solve it for y, and that plus or minus pops up, that's a pretty good indicator that that's not going to be a function. Does that make sense? Okay, all right, so solve for y if you can. That will be helpful. Okay, let's look at the next one. Okay, again, we're going to look at, does each value of x have exactly one value of y? One thing that you can always do on these problems is just pick a number. Okay, I'm going to start that way. Now I'm picking numbers that are kind of nice and simple. So I'm going to say, let's just pretend like x is 4. Well, you would have the equation 4 equals absolute value of 4y. Okay, now I want to ask you this. Do you know how many solutions that equation has? 2. What are they? You can do this in your head. -1. 4 times 1's 4. What else? -1. 4 times -1's -4, but absolute value of -4 turns back into that. The way that I taught you how to solve an absolute value equation is like this. What you do is you just say, you solve 2 equations. You say that, and then you say 4y equals -4. But the point is you're going to get 2 answers, so this is not going to be a function. So notice on this you get y equals 1, and over here you get y equals -1. So what you had is basically, you kind of have this. If x is 4, then that maps to a 1, and it maps to a -1, and you can't have that. So that's not a function. Okay? So that's one way to do that, is just plug numbers in and see if you can find a place where you get 2 or more answers. Okay? All right, does that make sense? Okay, now these things right here you have to try something with, and you got to see if you can find anything that would make it not a function. That's just one approach to doing that problem. Okay, let's look at a couple of more here. Okay, let's do this. So let's see. Let's just say x is 1. I'm just going to pick a number for x. I'm going to plug it in. Okay, so I would have the equation y squared equals 7 times 1. So I'd have y squared equals 7. Okay, tell me how many answers there are to that equation. Y squared equals 7. There are 2. How come? Because you do the square root of both sides, that introduces the plus or minus, right? So what you would end up having is you would have y equals plus or minus square root of 7. So actually what we just showed is if x is 1, then we have 2 different answers. We have root 7 and you have negative root 7 like that. Okay, so what's the reason why it's not a function? Okay, so a lot of times it depends on, you know, the equation and how you set that up. The other thing that you could do on this problem is you could do the square root of both sides at the beginning, and what you would get is y equals plus or minus square root of 7x. So now it's pretty clear that no matter what you plug in for x except 0, you're going to get 2 answers. If you plug 0 in, you're going to have square root of 0, right? Which is 1 answer. So does that make sense? You're always going to get 2 answers for any x except 0. Okay, so that's why that's not a function. Okay, okay, let's take a look at this one a little bit. So again, same thing. One of the things that I always say that you probably should do if you can is take the equation and solve it for y. If it's not already solved for y, that's a good way to start the problem. Okay, so what I'm going to do is I'm going to divide both sides by x here. And what I'm going to get is I'm going to get y equals negative 9 over x like that. Okay, now the question is real simple. No matter what you plug in for x, I'm going to put a box there. How many answers are you going to get? 1. You're going to get 1, right? Okay, now you couldn't plug in 0, right? Because you'd have a 0 denominator. But if you do negative 9 divided by a number, you get 1 answer, right? So that means that one is a function because you're only going to get 1 answer out of that. Okay? Now kind of reason this out in your head. So it's just basically that's going to give you 1 answer. That's how that works out. Okay? Does that make sense? Okay, that's one of the harder parts of this section I find students struggle with sometimes, taking an equation and without graphing tell if it's a function or not. But those are some of the strategies you want to do. Okay, let's do one last thing here, and that will kind of get us through part of this. These chapter 3 sections are relatively short. So this is function notation. So this is the name of a function. If I ask you to find f of negative 2, what do? You probably know this from your background. Well, you just plug in. Everywhere you see an x, you plug in negative 2. That's giving you a y value. So basically, f of negative 2 would just be equal to negative 2 squared minus 3 times negative 2 plus 1. Okay, so that's going to be 4 plus 6 plus 1. So that's equal to 11. Okay, so what we get is we get f of negative 2 equals 11. And what that means is it means this. It just basically means that negative 2, 11 is on the graph. That's the meaning of that. So when you're dealing with functions, you're just, I'm giving you an x value right there, and you're finding the y value. That's it. Okay? How about number 16? Let's finish with number 16 and 17. What would you do on 16? Everywhere you see an x, what are you going to replace it with? Negative x. It's the same thing. So what you would have is you would end up having this. You would have f of negative x equals 6 times negative x squared minus 4 times negative x plus 6. And then, of course, you just work it out. So what's negative x squared, this part right here? I'll just go back to positive, so that's 6x squared. How about this part?
Plus 4x.
Positive 4x plus 6. So you just get a new function. We've already done that before when we were looking at odd and even functions. That's kind of how we started the problem off, like that. Okay? All right, then the last one. Okay, we just plug in negative 7. Everywhere we see an x, we plug in a negative 7. So we'd have negative 7 minus 6. Negative 7 plus 7, so that's negative 13 over 0. So what do you conclude?
Undefined.
You're undefined. So a function does not have to be defined. On that case, you would just say we're undefined because we get a 0 denominator. That's it. Okay? All right? So everybody okay with what we did today? I think you probably will be okay with this kind of stuff. Okay? When chapter 3 starts, it starts off pretty simple. Okay? And I'll go ahead and load this video and post this if you need.